Okay, Mr. Appleby asked me to explain about how to graph sine waves and the idea of phase shifts. Now, in higher level math, we looked at this equation a little differently than you're going to look at in physics. In math, we simply look at the transformations that are happening here. So we see, first of all, it's a sine wave. Now, you might have studied this in 10th grade. We're going to go over it again, but I'm just doing this as a favor from Mr. Appleby. We have a sine wave. Okay, what's the first thing we see? The first thing is the horizontal shift of pi. So the first thing is we're moving it pi to the right. What's the next thing we see? The next thing is a horizontal stretch by a factor of 1/3, right? And then the last two things, we do a vertical stretch of 7, and then we do a vertical shift of 2. Now, for mathematical, we see the four things that are happening here, but the question is, what happens? What is the final? What's known as the phase shift? What exactly is the result of doing these two horizontal transformations to the sine wave? It turns out if you move it like pi to the right and then shrink it by 1/3, this is known as the phase. There's a phase shift of pi over 3. And we can see that. We see that. And then when I first started teaching this to you guys, I said, factor out the 3. So let me get another color. So if I factor out the 3 and I write this as 7 sine of O parentheses 3 O parentheses x minus pi over 3, this is our phase. This is the resultant of both transformations. So that's the idea. That's where the pi over, that's a phasor. So at the end, when we graph the sine wave, the final movement along the horizon is a shift of pi over 3 to the right. Once again, we moved it pi to the right, and then we shrunk it by 1/3. And then basically that's the idea. Now we can, if you recall from last year, so for example, so what's going on here? Well, we have a sine wave. So this is how I'm going to be teaching it. First, So let's see. We have a sine wave. Okay. For us, we have a sine wave. Let's see. What do we have? So we have a vertical stretch of 7. Therefore, the max is 7 and the minimum is -7. But we have a vertical shift of 2, so we added 2 to this. So our maximum is 9 and our minimum is -5. Okay? So we can draw that in there. We have a sine wave. It's a sine wave. There's no reflection. And we have a maximum of 9 and a minimum of -5. Let's see, that's 9, -5. The midpoint here, the midline is 2. Okay. Now the question is, what is the wave here? Well, if there was no phase shift, we would say, okay, well the frequency, if you recall from last year, the frequency is 3. Therefore, the period is 2 pi over 3, or 120. So the way I'm going to teach it to how to sketch these graphs is, you're going to make this from because of a frequency of 3, the sine wave repeats itself 3 times over 3/6 or 2 pi. Therefore, we get one full cycle over from 0 to 120, or 2 pi over 3. Now, if this is 2 pi over 3, this middle point is pi over 3. This is pi over 6, or 30, and this is pi over 2, or 90. Once again, you should have learned this last year. We're going to be learning it again this year. Now, the last thing we need to take care of is this phase shift, and that the idea is that this whole graph gets shifted to the right 60 degrees, right? So it ends up, well, this is 30. Yeah, so it's kind of like this, right? And that's the idea. There's a shift, right? The shift of pi over 3. And I believe that's the idea. So I'm going to send this video to Mr. Appleby. I'm going to wait for some feedback, and that's the idea. So once again, we know from our HL class, the horizontal shift and then the horizontal stretch together, combined, the resultant horizontal change is our phase shift. And you can find, you'll see that if you just factor out the 3, this gives us our phase shift of pi over 3.